Hi, 08. This is Unit 7, Lesson 5, and today we're going to talk about similarity criteria. So yesterday we saw that two triangles are similar if their corresponding angles are equal and their corresponding sides are in proportion. Now, just like with congruence, I don't have to prove all of those things. We can prove that two triangles are similar with less information. So I'm going to take the picture that's here in exercise 1, but I'm actually going to change up what they're asking. So I really just want to explain this. So I'm not going to really look at these questions right here. But in this exercise 1, I know that angle A is congruent to angle D, and that's marked. And angle B is congruent to angle E, that's marked. All right? So now I want to ask you, what would be true about angle C and angle F? All right, let's make up some numbers. Let's say that angle A was 60 degrees. Well, that means angle D is 60 degrees. And let's make up a measure for angle B. Let's say angle B is 50 degrees. Well, that would make angle E 50 degrees. Okay? So now let's figure out what angle C and angle F are. Remember, the three angles of a triangle add up to 180. All right, so if angle A is 60 and angle B is 50, that's 110, and 180 minus 110 is 70. So that means there's 70 degrees left for angle C. And let's do the same thing with triangle DEF up there. If angle D is 60 and angle E is 50, that's 110, and 110 subtract that from 180 is 70. Okay, so even though I only have two angles congruent to two angles, all right, the third angles automatically have to be congruent. All right, so when I have similar triangles, all three angles are congruent to their corresponding angles, but I don't have to prove all three angles. I just have to prove two angles are congruent. That's enough. All right, so that's going to be our most popular method of proving that triangles are similar to each other, and that's right here. So the angle-angle criteria for similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles automatically are similar to each other. All right, so this is the most popular. It's the only method that we're going to use for proofs. All right, so speaking of proofs, let's do a proof. So in this diagram in exercise 2, QR is parallel to NP. So I'm going to put that on my picture. All right, and I want to prove that my triangles are similar to each other. So remember, proof, I got statements on the left, I got reasons on the right. I know a lot of you did not like doing proofs for congruent triangles. These are much, much easier, but they're done, they're very similar. So QR is parallel to NP, given. Now, think about the fact if they're parallel, what would be true about angle 1 and angle 2, and what would be true about angle 3 and angle 4? Well, if you were thinking, oh, they'd have to be congruent because they were corresponding angles, you're absolutely correct. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And the reason is that corresponding angles, remember the lines are parallel, so those corresponding angles are congruent. And I'm trying to prove that the triangles are similar. So I got triangle MQR, which is the smaller one. You basically have a triangle within a triangle. Is similar to triangle MNP. That's the bigger one. And why are they similar? Angle-angle. Okay, they have two angles of one triangle are congruent to two angles of the other triangle. There's another step I could have put in there and I didn't, but those triangles also share angle M. Angle M is in both of them. So I didn't need it here because I only need two angles, but you could have written angle M is congruent to angle M, and the reason is reflexive property. So just like we use reflexive all the time with sides, I can use that with an angle. All right, and then let's try a little math problem. So in the above diagram, MQ is 8. So this side right here is 8. NQ is 6. NP is 21. And I'm trying to find the length of QR. Okay, now since the triangles are similar, I just proved that the sides are in proportion. So I'm going to take the two sides from the smaller triangle. I'm going to highlight it there for you, same color, blue. So 8 and x, so I'm taking the two sides from that smaller triangle, 8 and x, and then I have to take the two sides from the larger triangle. So this side and this side. So since I did the left side and the base, so the left side went on top and the base went on the bottom, I have to do the same thing. I need, though, the whole left side. So I need to know this whole side. The top part is 8 and the bottom part is 16. Well, that makes this part 14. So that's super, super important. That whole left side from the bigger triangle is 14, and the base of the bigger triangle is 21. So I got the left side of the smaller triangle, which is 8, the base of the smaller triangle, which is x, the whole left side of the bigger triangle, which is 14, and the base of the bigger triangle, which is 21. And then again, I just cross multiply. 14 times x is 14x. So you set up your proportion, and to solve a proportion, you cross multiply. 8 times 21 is 168. And then I just divide both sides by 14, and x is 12. All right, so similar to what we were doing yesterday. All right, let's flip this over. There are two other ways to prove triangles are similar, and that next way is the side-side criteria, side. All right, so basically if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar to each other. Okay, so if I have a triangle, and let's say the sides are 2, 3, and 4, and then I have another triangle, and the sides are 4, 6, and 8, those triangles have to be similar because all the sides are in proportion. They all have a scale factor of 4. So as long as you have all three sides, all right, of one triangle are proportional to all three sides of the other triangle, then those triangles are similar. And that's called side criteria. And then the next way is side angle side criteria. All right, and side angle side, it's different than the side, and side angle side that we did for congruent. All right, it means that the two sides are proportional and the angle between them is congruent. So say again, I have those two triangles, and say I know this is 2 and this is 4, and I know that this is 3 and this is 6, but I don't know the other side, but I know the angle between them is congruent. That's side angle side. So I have two sides in proportion to two sides of the other triangle, and the angles between them are also congruent to each other. All right? And down here is just sort of an explanation as to why those work, but also another picture. So if we're looking at this, you can see that the new triangle is 2 times as big, so all of these sides are in proportion. 6 over 3 is 2. 8 over 4 is 2. 10 over 5 is 2. So all the sides are in proportion to one another. So these are similar by side. All right, so I'm doing something a little different than what the directions say. I just want you to see it. And here, let's take these two sides. So 15 over 10, if you reduce it, they're both divisible by 5, is 3/2. And then 21 over 14, again, if you reduce it, divide by 7, you get 3/2. So you can see the sides are in proportion to each other and the angles between them are congruent. So those are similar by side angle side. So I'm using the same abbreviation, the same letters that I did when I was doing congruent, but this is just a little bit different. All right. Last one, in 5, in the diagram below, which of the following information would not be sufficient to show that ABC is similar to RST? So I either have to have angle, side, or side angle side. So I'm looking for which is not. That means 3 of them are going to work and 1 of them is not going to work. So let's look. RS over AB. So RS over AB. Okay. And then it says ST over BC. And then it says TR over CA. Well, that sounds perfect. They're just telling me that all three sides are in proportion. So that's side, side, side. Good. All right, 2 is saying AB, which I have in blue, over RS, which again I have in blue, AC, which I have in green, and RT, which I have in green. So I know those are in proportion. All right, I don't know this purple side, but I know the ones I have in blue and green. And angle A, which is between the two sides, and angle R, which is between the two sides. So this one's perfect also. That's side, angle, side. And then this next one, number 3, is showing us that angle S is congruent to angle B, and angle C is congruent to angle T. All right, and now let's look. Now look at the order of the letters. So S is congruent to B. All right, they're both the second letter, and C is congruent to T. All right, that's the third letter and the third letter. So those are corresponding, they're matching up. All right, so that is also okay. The last one, though, is saying that, it's saying that RT over AC, so RT, which is okay, over AC, those are corresponding, so far so good. And TS, which is here, does that match up to CB? Yep, it sure does, so that's okay. And then they said angle B is congruent to angle S. Well, that's no good because the angle has to be between the sides. In order for it to be side, angle, side, the angle has to be included between the two sides, so the angle is not between the sides. So that one would not be a method. Okay? All right, and we'll practice all those tomorrow.